This example comes out of section 5.2, transformations of sinusoidal functions. Okay, this question has multiple parts, and so it was worth doing some writing while I was paused there. The depth of water in a harbor is described by d of t equals 10 times cosine pi over 60 plus 14. So d is our depth in meters, t is time in hours after high tide. We're asked to do a few things from this, all of them pretty much relating to the graph, but we need to find the period of the graph the function for 24 hours, find the depth at a certain time, and then we'll worry about question D as we get down there to the end. Finding the period of the graph should be relatively straightforward. This little formula that says period equals 2 pi over b is not on the formula sheet, but it's definitely something worth remembering. The period of a cosine function is usually 2 pi, and if you do a horizontal stretch of 1 over b, you're going to have 2 pi over b. So in this case, 2 pi divided by this strange number of pi over 6. Well, 2 pi times 6 over pi actually gives us a very nice period of 12. In this case, it turns out that it's 12 hours. As long as you have a period of 12, you've got the idea. Now, when it comes to the graph, we need a nice set of axes. So I have something that looks like this. I have depth on the y-axis, time on the x-axis. At time equals 0, this graph is actually at its maximum, which is at 24 meters. So this water is 24 meters deep. Its period we just found is 12 hours. So after 12 hours, it'll be back to that same depth, and after 12 more hours, back to that same depth. Halfway in between the two maxima is going to be the minimum, and that turns out to be 4 meters here. And so if you even just connect the dots, you can draw a rough cosine curve that's going to go through these. You do have a calculator, obviously, that will allow you to get at least a rough picture of this to sketch from. But you have a graph that looks something approximately like that for the first 24 hours. Finding the depth when t equals 5 basically just means letting t equal 5 in the equation. Or if you have graphed this thing, you can use your graphing calculator, and we're going to need the graph for the next one anyway, so why don't you graph y equals 10 cosine of pi over 6 times x plus 14, and then to answer question C, you can just do second function, trace, value, and let x equal 5, and you'll find an answer for what y equals. So what I find when I do that, second trace value x equals 5, I find that y equals approximately 5.3. So the answer to A was this period, the answer to B was this graph, the answer to C is what we've just done, and we're getting an answer of about 5.3 meters deep. And we can even look at that on the graph and see that at time equals 5, this water is pretty close to its minimum. Now for question B, we want to do one other thing. That is, if the cruise ship requires 8 meters of water, I want to know when this depth is reaching 8. So I'm going to graph a second function here, and a very simple one, that's y equals 8. If I sketch that on the graph up above, it's just a horizontal line, and if I can find these intersection points in the first cycle, I can see when the ship has to leave the harbor and how long that's going to take. So in this case, we're doing second trace intersect, and we're finding two intersections, the first one and the second one, to see what times they are. So if you find these two intersections, I've called them x1 and x2, x1 and x2. The first one happens at about 4.2 hours, and the second one at roughly 7.8 hours. And realistically, you wouldn't round yet, get the decimals 4.22 and 7.77 or whatever they were. So it means that there's a total of 3.6 hours where this ship can't be in the harbor. 7.8 minus 4.2 is roughly 3.6 hours. And so we weren't asked that, we were asked how many hours it can. So really we're saying, well, the 12-hour period minus 3.6 hours is how much. And so you're going to get an answer of somewhere in the 8.4 to 8.5 hour range. Again, depending on where your rounding went. I modeled some bad rounding here, but to give you the idea of how to do the trig without getting too carried away. So this ship, out of 12 hours, can stay in the harbor for 8.4 hours.